another video. So in the previous video, we were using the VOS viewer to kind of analyze the interactions between different keywords and look at who is collaborating with who in terms of different countries and the different authors. So now we are going to look at another tool called BibliometriX. It's a software that runs in R Studio. Is based on Shiny, if you're familiar with that. So you can go to the website for BibliometriX, bibliometrics.org. And then next, you can open your R Studio. This is the default view that you're gonna get. So I'm just gonna go ahead and open the R script. The first code that you need is install.packages bibliometrics. Once it is installed, you want to load the library. I'm gonna go ahead and load the library because I believe that I already have it. So if you don't have it, then you need to run the bibliometrics install.packages. Some message here. So there's also an instruction here to say, to start the app, you need to run this biblioshiny open bracket and close bracket code. I'm just going to put a comment here, open the app. So I'm just going to go ahead and open it. So it's based on the browser and also runs on your local machine. So there's no need for the internet. So as you can see, this is addressed to my machine. This is the website. You can read the details here. Now we are going to come back here and load the data. So you remember the same data that we used for VOS viewer that we have downloaded on SCOPUS. Let me just look at the safety history. So we have downloaded this data by going here and then clicking on export CSV. So now you can read what it's all about. We go to the home, BibliometriX. So it says a full package for science mapping workflow. BibliometriX gives all the instrument to pursue a complete bibliometric analysis following the science mapping workflow. It has been created and developed by Massimo Aria and Corrado Cucurulo. I hope I'm pronouncing it right. But there's also a number of tutorials that are available on their page as well. So for now, let's just go ahead and do some basics. You can always explore this on your own. I'm going to go ahead and load the data. It says, please choose what to do, import raw file. So I'm gonna go ahead and choose that. The database, Web of Science, no, we are using SCOPUS. So we need to make sure that we select the correct option there, because otherwise the software will not be able to read the format of the file. So we're going to go ahead and say choose file and navigate to our downloads. This is the file that we had, Scopus 1, and then it says upload complete, then you can say start. So now you can see like the completeness of the metadata that is there within the spreadsheet that we have. Majority of them are excellent. In terms of the DOI, it is good. The keywords are good. The corresponding author, it says, is acceptable. Keywords plus is poor. And cited references as well, science categories are missing, completely missing. So we can just continue. So here you can be able to kind of visualize the spreadsheet as it was as well. So the first thing I want us maybe to look at It's just the different options that are there. There are filters that you can apply. For example, these are the same ones that you can use, that we have used on SCOPUS, the filtering by the date, the article type. So in this case, because we didn't download the entire data set, we had kind of filtered it out according to language and the publication years and the document type. It is only showing those ones as options. So we don't really have anything to do with this, and we can't do anything with this information. So we can look at the annual scientific production. I've never used this main information plot. Just shows you kind of the statistics, international co-authorship, annual growth rate in terms of articles and so on. And we'll also show you this in a form of a table. So let's look at the annual scientific production. Once you click, it already generates the number of articles per year. So you'll see that there's a very increasing trend, particularly between 2017 and 2019. There's a sharp increase in the number of articles. And again, after 2019, 2020, until 2022. So this might have been because of COVID. A lot of researchers had time to kind of do more research. The 2017 to 2019 trend could have been because of the launch of Sentinel-2 and Sentinel-3 satellites, as well as Landsat-8, which kind of got the interest from the researchers. You can look also at the average citations per year. You will notice the citations went down in 2010 on this topic and went up again starting from 2010 up to 2012. So there was some fluctuations as well, and it has went down again during 2023. The three field plot, it doesn't work. So in this plot, you can see like the source's local impact by H index. So you'll see the main journals that are being that are investigating this topic is rangeland ecology and management, remote sensing of the environment, and so on. So you'll see these are the different journals and the number of kind of times they are cited or their H index. The sources production over time. So the sources is looking at the journals themselves. So you'll see, I can see the legend here, or it's at the bottom. So the rangeland ecology is the leading one, and you can see like its productivity over time. So it's kind of very high across the entire time series when compared to the other journals, right? So if you're going to looking at the authors, you can look at the most relevant authors. So for some of these functionalities, you need to click this play button to run the analysis. So you'll see that similar to the view as viewer results, Prof. Mutanga is kind of leading in this field with the number of documents being around 14 during the time period of 2003 up to 2023. This is followed by Dr. Sibanda, then Prof. Ramuelo, Prof. Dube, Jafari, Odindi, and so on. And yeah, you can see these are the main players in this field. You can see their production over time or productivity over time. You'll notice that Prof. Mutanga started this journey way earlier than the others that are in this field, and his kind of output has increased over time, and others have kind of started researching on this particular topic recently. So we can be able to see this nice trend. So these are some of the plots that you could include as well in your bibliometric analysis. You can generate other types of plots, such as the author's law, author's local impact. Yeah, this is similar to the one with the most relevant authors, but this time it shows the H index, kind of which author gets cited more in this particular topic or field. So in terms of the most relevant affiliations, in other words, which organizations are kind of researching this, you'll see University of KwaZulu-Natal in South Africa is leading. This is because Prof. Mutanga is associated with this university, and therefore, because his contribution is higher, the university's contribution is also high. There's also Isfahan University of Technology, the University of Madrid, California, and so on. So most of the authors actually that are kind of leading here, for example, Mutanga, Ramuelo, Dube, they kind of come from, or they kind of used to be affiliated with University of KwaZulu-Natal. So it's not surprising that is highly performing in this particular field. And in terms of affiliations, we can also look at the productivity over time, right? So you need to press that play button. So if this information is interesting for you, you can also include it in your bibliometric analysis. So you will notice the UKZN is the pink line, and it was kind of quiet in the past. It was Fort Collins was higher, and then it kind of picked up around 2015 and kept a steady increasing trend like that. So in terms of countries, you can also analyze the corresponding authors' countries. So you'll see the United States of America. I don't know what are these, MCP and SCP. You can always go and investigate and read the bibliometrics documentation to find out. But yeah, you can see how the corresponding authors' countries, or the different countries in which the corresponding authors are coming from. You can look at this country's scientific production over time. So this is a map, which you can also download to your document as well to visualize it. So United States is leading with 375 documents during the period under review, followed by China, 119. So followed by South Africa, I think. Yeah. And the other countries. So you can see the country's production over time as a line graph. Seeing USA is kind of surpassing all the other countries. And I'm sure there's many reasons why. And then there's South Africa as well. Very close to Argentina. You can look at the most cited countries. Remember, you have to run this button whenever the plot doesn't appear. So these are most cited countries: USA, followed by South Africa, and China, Argentina, Australia, Iran, and so on. So let's look at the documents option. Most globally cited documents, most locally referenced, reference spectroscopy, references spectroscopy. Yeah, some of these options are not running. Could be because our spreadsheet is missing some of the information. Most globally cited documents, you can see the journals, the people, the authors, and the journals where they've published these documents. One of the interesting one is this, the word cloud, but let's look at the most frequently used words. Rangeland is the leading one, of course, and remote sensing, NDVI, vegetation, Landsat, United States, and others. But I'm more interested in the word cloud, especially if you're doing like the presentation for your proposal and whatever. You can always use this word cloud to kind of highlight which keywords are mostly researched. So the bigger the keyword, the more researched it is in this topic. The other types of plots, tree map. This is also one of my favorites. You can see similar information as well, but it also displays the percentages as well in terms of how much it's being researched. Words frequency over time is another plot that you can have. Trend topics. So you'll see how these different keywords have kind of been researched over time. So earlier on, people used like AVHRR because it was maybe the interest was mapping at a larger scale. And as time goes by, you see things like Sentinel because it has been recently launched, right? Let's look at the clustering. What is there? It doesn't work. So similar to the VOS viewer, you can look at the co-occurrence network. This is what we have visualized in VOS viewer, but my opinion is that VOS viewer does it much better than this. Hence, it's better to use the VOS viewer. You can look at the decree plot, the thematic map. So this is one of my favorites, right? Because it kind of shows you the basic themes, motto themes, the relevance centrality line, as well as the development degree line. And this side, you see the emerging themes such as vegetation, agriculture, time series analysis, and so on. And there are also niche themes, so like climate, ecosystems, season, and so on. These are kind of multidisciplinary researches and machine learning algorithms and so on. So this is very kind of interesting, particularly if you're still kind of trying to find your topic and so on, or even your literature review to just highlight which topics are kind of niche, which ones are emerging, are kind of less researched and so on, so that you can focus on those ones that are less researched than the ones that are kind of basic themes or have been more researched. So you can look at the clusters, just like we did with the co-occurrence map in VOS viewer. But this is definitely one of the plots you would kind of want to include in your bibliometric analysis. So yeah, just go and explore what you can do with this and what could be very interesting things. So you can do factorial analysis here, 2 dimensions. One explains like 19% of the variability, another 21%. and you can see the different keywords and where they fall onto, right? You can look at the topic dendrogram as well, the clustering of the words, and the articles by cluster. So yeah, just go and look at it in detail and decide which kind of plots will be more interesting for you. So there's also some clusters here, which is something that our plot on view as viewed couldn't show. So you can see some people that are collaborating, say in this cluster, Mutanga, Ajololo, Odindi, Sibanda, Roget, Cho. So this is the kind of people that are kind of collaborating together, particularly in South Africa. And so, yeah, this could be another region. So authors from different countries, basically, or different institutions that are kind of researching on the same topic. So yeah, you can display the same information as density plot. So you see the South African group is very active in this field. So in terms of the countries collaboration, you can also look at it using the map and look at the interactions between the different countries using these lines. So the thicker the line, the more collaboration, the stronger the collaborations between those countries. So you can also generate a report. So you'll notice that on each of these plots, for example, you can say download, you can download it, or you can add the results to the report. So once you have done this, like added all the results to the report, when you're done with the bibliometric analysis, you can go ahead and download the entire report, right? You can just export it. You can even select the ones that you want, the final ones that you want, and then export the report. It will export as a XLS file. If I try to open it, but yeah, otherwise, I hope you learned a lot. And I'm looking forward to seeing this kind of plots in your documents. So you'll see this is this is the plots that we generated and the tables, which you can now refine and put in your literature reviews. So I hope you learned a lot, and I'll see you in the next video where we are going to be discussing using the Mendeley Reference Manager and Mendeley site in order to manage your references. Cheers.